Welcome back, folks. In today's class, I'll talk about the static force. Static force. Now, static means when the object is not moving. So, for example, if this is an object which is placed on the ground and I'm applying certain force in the forward direction, which is 100 Newton, and the object is still not moving, even though I'm applying 100 Newton force. Why? Because the force of friction in that scenario is more than obviously the 100 Newton force which I'm applying. If the force of friction was less, then the object would have moved. But I guess in this case, maybe it is 101, 102, 110, we don't know. But the fact is that this force is bigger, force of friction is greater than force applied, then the object will not move. And that's a condition of that the object is static, it's not moving. All right. So another example can be if there is a board sign which is hanging from a wall. So in this case, let's say this is a board sign and which is hanging from a wall. If it is not moving, then this is also a static condition. So how to write the equations for when the object is not moving or under the static conditions? So force net is equal to force applied plus minus force of friction. And this is the formula we learned in the last class. So same formula we can apply, and this formula is in the horizontal direction. So if the object is not moving, net force is 0. So force applied will be equal to force of friction. All right. And then another condition will be that for the vertical one, that will be force net is equal to, oops, force net is equal to force applied minus force due to gravity. And again, this is not moving, so gravitational force is Fg, which is equal to force applied. Okay, that's how we gonna approach these questions. Now, if I look into this question thoroughly, if I try to look into the detailed examination of these formulas, especially the horizontal one. So the formula was F net equal to force applied minus plus minus force of friction. That's what we wrote. So I'm going to take an example with this. This is an object placed on the ground. 100 Newton force you are applying in the forward direction. I wanted to find out how much force of friction which is acting on this object when the object is not moving. So this will be force applied. If the object is not moving, net force is 0. This is 0. And plus minus force due to gravity. I can move it on the other side. I can say force due to gravity is equal to force applied in that scenario. All right. And you wanted to keep the plus minus. That's fine. Depending upon, again, as I said in the previous class, depending upon which direction the force applied is, opposite to that, the force of friction will be. Okay, I made a mistake here. I accidentally wrote it as force due to gravity. It should be force due to friction. So it is force due to friction. Now, this is the this is what we got. So applied force was 100 Newton, and force due to friction will obviously be equal to 100 Newton in that scenario. So if the applied force is in the positive direction, force of friction will come out to be in the opposite direction. Force of friction will be negative 100 Newton. So what does we do in this cases? As I said, this is the formula which I used. But what happens is the thing which we are trying to find out right now, I'm trying to find out the force due to friction. So then I will write it as positive. Okay, if this force of friction is given to you, you are trying to find out the net force, then you will select the sign. If the force of friction is what you're looking for, then you will only place it as a positive sign, only as a positive sign, force of friction, and then let the equation find out in which direction the force of friction will be. So this is F net. Again, as I said, I'm trying to find out the force of friction. It is not given to me. So thus I won't use plus and minus. And then net force is equal to 0. Force applied is equal to, well, force applied plus force due to friction is equal to 0. This goes on the other side, becomes negative force applied, which is equal to shall I say negative of force of friction equal to force applied. Now force of friction equal to negative of force applied, and then force applied was positive 100 Newton, and the force due to friction came out to be opposite to that. All right. So that's how you're gonna approach these questions. You can also apply the technique which I earlier told you, that the force of friction will always be opposite to the force applied, and so you can put the negative sign later on too. But this is more of a correct approach to solve a question when you are asked to find out the force due to friction. Now we figured out the force due to friction, which came out to be negative 100 Newton. Now I'm going to take another example. This, let's say the same box. I start applying the 200 Newton force and the object is still not moving. Then how much is the force of friction in the opposite side? So again, we will write the formula. F net is equal to force applied minus force of, well, I'm trying to find the force of friction, so I'll keep it as plus force of friction. So net force is 0, force applied is 200 to the right, plus force of friction, which comes out to be force of friction equal to negative 200, and that's what uh, it will be equal to. So negative 200 Newton. So if I look into both the question, when I was applying 100 Newton force in the positive direction, then force of friction was 100 Newton. Only 100 Newton force was acting in the opposite direction. On the same box, it's still not moving. I'm applying 200 Newton, and how much force is acting in the backward direction? 200 Newton. So this force, applied force, is dictating the terms. This is deciding how much the force of friction is. But this will only dictate terms up to a certain level. That's what we're gonna see. Up to how much? What is the threshold value after which this applied force cannot dictate the term? The force of friction will have some threshold value that it cannot go beyond that limit, and we'll see how we can calculate that. So if this is a box which is placed on the ground, and force, again, there will be a force of friction. So how much is that? Let's say the mass is m, which is acting downward, and force due to gravity, if I see the gravitational force acting on this is downwards, Fg equal to mg. Okay, and this is equal to force due to gravity. And Newton's third law says that every action has an equal and opposite reaction. So every action has an equal and opposite reaction. So the easiest example I take is, if I slap anyone, he's gonna slap me back, maybe twice. Anyhow, jokes apart. So if this is a wall and you punch into this wall, and then you will also get hurt, isn't it? If the wall is strong. So that's what happens, because you apply 15 Newton force on this wall, the 50 Newton force will be applied back on your body. And this is why we walk also. You apply certain force on the ground with your front foot, and that applies the force back, and thus you've been able to lift the other foot and place it in the forward direction. So that same rule we can apply to this question also. I'm applying certain downward force, although it is not moving, but the certain force is being applied by this box in the downward direction. So equal amount of force will be applied in the opposite direction. And that's called a normal force, because that is acting at a 90 degree. Anything acting at a 90 degree is called normal. So normal force will be equal to mg. This is, again, this was in the downward direction. So I can, this arrow is showing downward, so I don't need to put a negative sign here. And this arrow is showing me the direction, so this magnitude is equal to mg. Now gravitational force, we got it, and then normal force, we got it. Now frictional force, the formula for frictional force will be equal to mu mg. That's how we calculate the maximum frictional force. In the previous case, you might have noticed this 100 Newton was there because 100 Newton was applied in the forward direction. If 50 Newton was applied, 50 Newton would have acted. Now, the maximum force of friction can be equal to equal to, force of friction max equal to mu times mass times gravity. That's what it is. Now, what is mu? Mu is coefficient of friction, and this value can vary, okay, depending upon what kind of a surface it is, what kind of a surface of the other material has. Depending upon those conditions, the mu value will change. Now, when to use this formula? I'll keep it really simple, that when we're going to use force of friction max equal to mu mg. If the coefficient of friction is given to you, this is the coefficient of friction. If mu is given, or you are asked to find out the mu, you are asked to find coefficient of friction, then we will use this formula, force of friction max equal to mu mg. Otherwise, we don't need to use this formula. Now, let's see the question. This is there is a certain object placed on the ground. Let's say, for the sake of question, I'll use the mu value is 0.5. Okay, that's given to me. Now, coefficient of friction is given to me. I wanted to find the maximum frictional force. That's what I wanted to find out. So maximum frictional force value will be equal to force of friction max mu times mg. I'm gonna say, for the sake of question, I'm gonna take the mass as 20 kgs and g value as 10 meters per second. Again, this is 9.81, but just to make my calculations easy, I'm using the 10 as the number. And the force of friction max in this scenario will be 0.5 times mass is 20 times 10, and that will come out to be 100 Newton. So for when the coefficient of friction was 0.5, the maximum force of friction can act as 100 Newton. What does that mean? If I am applying 50 Newton force in the forward direction, only 50 Newton, how much force acting in the backward direction? I cannot call it as 100 Newton, because if the force of friction is 100 Newton, then the object will start moving backwards. These are two unbalanced force. 100 Newton acting backwards, 50 acting forward, the object should move in the opposite direction, but it does not. So what's happening is only 50 Newton in that scenario is acting in the backward direction. But what I'm trying to say is this is the threshold value. So you can go here from 50 to 51, 55, 57, 100. Then the same time the force of friction will increase, but force of friction can only increase up to a number of 100. As soon as, if the applied force is 102 Newton, then the object will start moving in the forward direction. We've overcome the maximum force of friction. So hopefully you were able to understand the concept of maximum force of friction and the force of friction. So uh, I'll see you with another video later on. Bye now.